Okay, so this is a problem that a student asked me. This is from section 5.4, problem 10. I think in one class I solved this problem. I don't remember now exactly. It says let P be defined as the plane x plus 3y plus 2z is equal to 9, and let L be the line defined as xyz is equal to 2, 1, 0 plus the parameter t plus k plus 2 for y, and 2. And then we have to find the values of k such that the given condition is satisfied right here. Okay, before we start with the questions, let's just describe what is going on. So I have a plane, right, in 3D. I have three variables, and obviously, in order to be able to ask this question, the line also has to be in the same space. So I have line in 3 dimensions, 1, 2, 3 variables. Okay. So for what values of k, the plane and the line are orthogonal. So as I said in class, it's always easier just to try to represent this with some kind of sketch. So let's say that this is our line. Okay, so this is the line L, and this is P, the plane P. From the definition of the plane, I can figure out right away what? The normal vector. So the normal vector is 1, 3, 2. Okay? Well, if the line intersects the plane and makes 90 degrees with the plane, the normal vector also makes 90 degrees with the plane. That means that these two are parallel. So the normal vector and the line are parallel in the case where the plane and the line are orthogonal. And one more thing now, what is the direction vector of the line? Well, the direction vector of the line is k plus 2 and 2, right? So there is some vector here, k plus 2 and 2. Okay, and what did we say? Well, two vectors are parallel, right? These two vectors are going to be the same. Okay, they're going to be a constant multiples of each other. Okay, so let's try with the easiest idea. 1, 3, 2 is equal to t is 1 times k plus 2 and 2, and for here obviously k is equal to 1. You see, if k is equal to 1, and you're done. Okay. Okay, in the second case, we have the plane P here, and the line L. That is, it says that these are parallel. Okay, there is no common point between the line and the plane. But if L, the line, is parallel to the plane, then what? Then the normal vector is orthogonal to the plane but also to the line, because the line and the plane are parallel. Well, when we talk about orthogonality, we talk about the dot product. So in this case, n dot product, the directional vector of the line, or the vector parallel to the line, which is k plus 2 and 2, has to be equal to 0. Well, now we solve this. N is 1, 3, 2, dot product k plus 2 and 2, and this is very simple. That's k. 1 times k is k, 3 times k is 3k, plus 3 times 2 is 6, plus 4 is equal to 0. And from here you just have to solve for k. For k is equal to negative 10, or k is equal to negative 5 over 2. So one more time, if the line is parallel to the plane, then any vector orthogonal to the plane will simultaneously be orthogonal to the line. Well, I have a vector normal to the plane. That's the normal vector. this one here. If the vector is normal to any, if the normal vector is orthogonal to any vector on the plane, then it will be orthogonal to any vector parallel to the plane. Well, what is that vector? That is the vector parallel to the line k plus 2, and 2. And finally, for what value of k do the plane and the line intersect at this particular point, 8, 3, negative 4? Okay, so in this case, you have the line piercing through the plane at the point 8, 3, negative 4. Okay, and we have to find for what k this happens. Okay, so first of all, from the equation of the line, every point on the line satisfies this equation. So t times k, tk, t times k plus 2, tk plus 2t, and finally here 2t, which implies that x is equal to 2 plus tk. Every x on this line can be expressed as 2 plus tk, y is equal to 1 plus tk plus 2t, and z is equal to 2t. Okay? So every single point on this line satisfies these equations. Okay? So I want to find t and k such that x is 8, y is 3, and z is negative 4. So let's plug this x, y, and z here for the appropriate x, y, and z, and we get 8 is equal to 2 plus tk, 3 is equal to 1 plus tk plus 2t, and negative 4 is equal to 2t. Well, from the last equation, right away I have my answer for how much is t. T is equal to negative 2. Now you can plug this either in the first or in the second equation, and your question will be done, right? So if you plug here negative 2, you get 8 is equal to 2 minus 2k, and from here k is how much? Negative 3. And that is your answer. You have found the value for k for which the line crosses or intersects the plane at this particular point. If you want to make sure that that works out, you can always check whether it satisfies the third equation. So 3 minus 1 is 2 is equal to t is negative 2 times negative 3 plus 2 times negative 2, and check whether this adds up, right? So this is 6 minus 4 indeed is equal to 2.